Hello guys, welcome back to another class. So today we're going to do a new chapter, exercise 4.2 from the quadratic equation. So let us do question number 1. Here in question number 1 it says find the roots of the following quadratic equations by factorization. So let me do Roman number 1. X squared minus 3x minus 10 equals to 0. So first of all, what we have to do here is we have to do midterm factorization. 1 into 10 is 10. So first check the sign of the constant. Here the constant is negative. So the midterm will also be negative. Midterm factorization will be negative. So here in the middle there will be negative. So 10. What are the factors of 10? Factors of 10 are 1, 2, 5 and 10. So 2 into 5 is 10. So 5 minus 2. The product of these two will give us a product of these two. But the subtraction of these two numbers will give us 3. 5 minus 2 is 3. So now we have here x squared minus 5x minus and a minus plus 2x minus 10 equals 0. So here we can take x common, x minus 5. Plus here from these two we can take 2 common, x minus 5. So if we take out x 5 common, then we get here x plus 2. So here the roots of the quadratic equation are x equals to 5, x equals to minus 2. So these are the roots. Therefore the roots are 5 and minus 2. That's how we do it, guys. Now let's go to the next question. Okay, let me do number 3. Roman number 3. Root 2x squared plus 7x plus 5 root 2 equals 0. So first things first, midterm factorization. Can you see the sign of the constant? Here the sign is plus, so here in the midterm it will be plus. So multiply these two first. Root 2 into 5 into root 2. 5 into root 2 into root 2. Root 2 into root 2 is 2. 5 into 2 is 10. So this into this gives us 10. Now 10. 5 plus 2 is 10. 5 plus 2 is 7. And at the same time 5 into 2 is 10. So this is the value we have to put here. Now root 2x squared plus, remove the bracket, 5 root 2 equals 0. Let's take common. What can we take common? Nothing. So let's take x common. Root 2x plus 5. Here we can take 2 common. Root 2 common. Sorry. Root 2 into root 2 is 2. Root 2 into root 2x is 2x. Now root 2 into how much is root 2 into 5 is 5 root 2. So here we have 2x plus 5 x plus root 2 equals 0. So here for this x equals to plus will become minus 5 divided by root 2. Here x equals to minus root 2. So these are the roots. The roots are minus 5 by root 2 and minus root 2. Now let's do question number 4. Number 4 is 2x squared minus x plus 1 by 8 equals 0. Here we have a fraction. The constant is a fraction. So let's remove the fraction. By taking LCM we get 1. So 1 and 8. 8 into 2 is 16x squared minus 8x plus 1 equals 0. 8, 0 becomes 0. So we have here 16x squared minus 8x plus 1 equals 0. Now 16 into 1 is 16. Here 8. the constant is plus, so here the midterm factorization will be plus x plus 1 equals 0. Now 16 into 1 is 16, so but the sum of the two factors, the sum of the product of the two factors should give us 8. So let's see. 16, 4 into 4 is 16, right? 4 plus 4 is 8, so we can write that 4 plus 4 is 8, 4 into 4 is 16. So we have here 16x squared minus 4x plus 1 equals 0. From this two we can take 4x common, 4x minus 1 common, 4x minus 1. Minus into minus is plus. When we are taking common, then plus will become minus, because minus into minus is plus. Anyway, 4x minus 1, if we take common from these two, then what do we get here? 4x minus 1 into 4x is this, 4x minus 1 into 1. Here x will be, for this, if we credit the 0, 1, if we shift to the right hand side, it will become plus 4, 1 by 4, here 1 by 4. So the roots are 1 by 4 and 1 by 4. They are same roots. Alright. Let's do the last Roman number. Let's do the last sum for question number 1. Roman number 5. 100x squared minus 20x plus 1 equal 0. Alright, so 100 into 1 is 100, so it is 20. The constant sign is plus, so in the midterm should come plus. 100x squared minus something plus something should give us 20 plus 1 equals 0. So 100, so what plus what should give us 20? Let's see. 25 plus. Okay, I'm writing down the factors. Okay, let's just do like this. 2 into 50, 2 into 25, 5 into 5. 5 into 2 is 10, 10, yes. 10 plus 10. 10 into 10 is 100. 10 plus 10 is 20. Simple. 100x square minus 10x plus 1 equals 0. From this two we can take 10x common. 10x into 10x give us 100x squared minus 1 common, 10x minus 1 equals 0. 10x minus 1 equals 0. So x equals to 1 by 10 equals to 1 by 10. So the roots are 1 by 10 and 1 by 10. Now we will do question number 3. Find the two numbers whose sum is 27 and product is 182. Exercise 4.2, question number 3. Here we have to find two numbers. We don't know these two numbers, but the sum of the two numbers will give us 27 and the product will give us 182. Okay, so keep this in mind. Sum. Okay, so let the two numbers be x and y. The two numbers are sum will give us x plus y equals 27 according to question. So from here we can write x equals to 27 minus y. Let this be question 1. Then product x into y equals to 182. Now let's put x value here. In place of x we will write 27 minus y. So here putting x equals to 27 minus y, how much we'll get here? 27 minus y into y equals 182. So 27y minus y squared equals 182. Now let's bring it to the other side. Let's write y first plus 27y 182 equals 0. If we take y minus common, then see here, I took minus common. Minus into plus is minus, minus into minus is plus, minus into plus is minus. So where did the minus go? Minus 0. Let's write here 1, minus 1. 0 divided by minus 1 will always give us 0. So minus cancels. So now we have here y squared minus 27, y plus 182. Y squared minus 27y plus 182. Yep. Now, the product of the first and the here midterm factorization, the constant is positive, so it should come positive. I mean plus, yeah, addition. So now, something plus something should be equal to 27, and the product should also be equal to 182. So let's check the LCM of 182. 2, 9, 2, 1, 7. 7 into 1 is 7, 21, 7 into 3. 7 into 2 is 14. 14 into 13 is 182. 14 plus 13 is 27. So we can write here 14 plus 13. The sum of these two will give us 27. The product of these two will give us 182. Simple as that. 14y minus 13y plus 182 equals 0. Now here we can take y common, y minus 14. Here we can take 13 common, y minus 14. Because 13 into 14 is 182. Y minus 14, y minus 13 equals 0. Now, here we get two values of y. One is 14, one is 13. Now, putting value of y in equation 1. Let's see, if y equals to 14, then what is equation 1? Equation 1, x equals to 27 minus y. 27 minus y. So 27 minus 14 will give us 13. Let's check whether this is correct. So no, actually, so yes, if we take y equals to 14, x will be 13. So the two numbers are 13 and 14. It's the same thing. If we take y 13, then x will get 14. So it's the see, y is 13, so the two numbers are 13 and 14. It's the same thing. We don't need to again do it taking y is equal to 13, because we know that if we take y 13, then we will get x 14. So the two numbers are 13 and 14. The sum of these two will give us 27, and the product of these two will give us 182. So that's it. Now let's do one more sum here. Let's do question number 4. Question number 4. What does it say here? Let's see. Find two consecutive positive integers, sum of whose squares is 365. See, consecutive numbers means one after another. So let the consecutive numbers be x. If one number is x, then the other number is x plus 1, consecutive, one after another, like 76, 77. So 76 plus 1 is 77. So what if the other one number is x, then the other number will be x plus 1. Here is the sum of whose squares is 365. The sum of these two squares will give us 365. So let's see, x squared plus x plus 1 square. The squares of these two numbers will give us 365. Let's open up the square. A plus b whole square formula: a squared plus 2ab plus b squared. X plus x, 2x squared, x squared plus x squared, 2x squared plus 2x plus 1 minus 365 equals 0. Now 2x squared plus 2x minus 1 minus 365 is minus 364 equals 0. Now the constant number is minus. Let's do midterm factorization. For midterm factorization, it should come here, it will be minus because the constant term is in minus. So 364, 728. I think 364 into 2, this into this. 24 is 8, 26 12, 23 6, 7, 728. Yes. So the product of these two gives us 728. So something minus something should give us 2, but the product of these two should also give us 728. So let's check the LCM. 2 into 3 6, 2 into 6 12, 2 into 4 2 into 1, 2 into 8, 2 into 2, 2 into 9, 2 into 1, 7 1 3. So that's it. Let's see. 7 into 2 is 14. I'm doing this combination, this and this and this 3 combination. 7 into 2 is 14, 14 into 2 is 28. 13 into 2 is 26. 13 into 2 is 26. Yes, 28 minus 26 is 2. And 28 into 26 will give us 728. So we can use this combination. This is trial and error method, okay? I just did it, but luckily I got it in the first try. So see, 13 into 2 gives us 26. 7 into 2 is 14. 14 into 2 is 28. 28 minus 26, 2. But the product of these two will give us 728. So here we can write 28 minus 26. Let's open up the bracket. 28x minus 26x minus 364 equals 0. Here we can take 2x common. 2x into x is 2x squared plus 28 minus 26 common, x plus 28 equals 0. We already know here. No, 26 into 28 gives us 728. So here, look. 26. I totally made a mistake here, guys. I messed up big time. I'm gonna write here 2x common, x here plus 2x into how much will give us 28x. 2x into 14 will give us 2x into 14 will give us 28x. Here 26 is common, then we get here x. 26 into x is 26x. Minus into plus will give us minus 364. 26 into 14 will give us 364. Let's just check. 26 into 14, 4 into 6 into 4, 4 into 2 is 8, 9, 10. 1 into 6 is 1 into 2 is 2, 4, 6, 3. 364. Yes. 6 into 14. So now x to x minus 26. If we equate this to 0, we get x equals to minus 14. Sorry. If we equate this to 0, then we get x equals to 26 by 2. If we cancel, we get 13. So a number consecutive, what does it say? 2 consecutive In the question it's written here, find two consecutive positive integer. It's a positive integer, it can never be negative, so this cancels out and we have this x equals to 13. So the two consecutive numbers are x and x plus 1. So x is 13 and 14. So the two consecutive numbers are 13 and 14. That's it for today, guys. We'll do the remaining questions in the next class. Thank you.